Missed. AI is in the air.
Hi, good morning, everybody. Thank you for joining us on this nice Friday morning and in some cases afternoon for you. We are here to present to you a little bit of background on indoor location services and why we at MIST believe that it's going from a nice to have to a must have across various verticals based on use cases we have seen. So welcome everybody, live from Cupertino. It's Bob Friday on a Friday.
Thank you, everyone. And yeah, I think this is a follow-up to our Mobility Field Day show last week or so. And I think, you know, what we heard from Mobility Field Day is, it was kind of, why is, is indoor location really becoming a must-have? Is it still kind of a nice to have? And so I think we're trying to have a follow-up. What we talked about last week was around missed Wi-Fi services. And these are really kind of focused on Marvis and what we're doing to really build a system that can help answer questions on par with network domain experts, right? And really providing better visibility on the end-to-end user experience. And location tends to be one of those critical services that goes well with Marvis, because this is around the theme of people starting to put more of these services on their networks. As they put more critical services on the networks, they want better end-to-end visibility. So in this webinar, we thought we'd go a little bit deeper on the missed BLE services and what we're doing around the indoor location base. Anything else to add, Sunil?
No, that's right, Bob.
Okay, so I kind of wanted to start with, where are we, why is indoor location not really taking off up to date? And for me, there's been like 3 big reasons around indoor location being slow to get adoption. One is really around this technology. If you look, there's been a lot of indoor location technologies, but none of them have really been adopted by the mobile devices as a interoperable standard. For me, that friction point is being overcome by BLE now. When you look at all the different options on our phones right now, all our phones support BLE. Google and Apple have chosen BLE as kind of the proximity and indoor location technology that they're basically optimizing their OSs for, and Wi-Fi is becoming our connectivity standard. Having said that, if you look at all the different things happening here, you can see, there's this Wi-Fi fine timing, and that is something we are keeping an eye on and seeing how that gets adopted. The second thing that has really slowed adoption is really about overlay networks. Up to now, indoor location is almost always required an overlay network of some sort. And even the battery beacons looks like an overlay network to the IT guys. And that's where I believe at MIST and other companies, we're starting to converge Wi-Fi and BLE together. And that starts to eliminate this overlay problem where we're asking enterprise ITs to make a separate investment for indoor location. And probably the third hurdle has really been around indoor locations, always been associated with some sort of calibration. People have to go around, calibrate it manually. If you look at the airports, even Apple basically has a program that makes you walk around and calibrate that thing every year. That is going away. And this is where AI is starting to make a difference. When I was doing indoor location back in my airspace Wi-Fi days, I really didn't have access to all these AI algorithms. Now we can actually build algorithms that actually can learn the path loss models from actually device information. So we don't have to actually go out there and do those site surveys. And I also encourage, if anyone has any questions, please don't hesitate to stop. I'm happy to go even deeper if there's any questions coming in. So
Bob, I have a question, right? So on this slide that you're showing right now, indoor location has been around for quite a while, but obviously is not expanded beyond certain key verticals which needed location services as almost a mission critical network. Do you feel that given how Apple and Google are positioning and forwarding BLE technology as a predominant technology for engagement, that we will see more and more use cases, more and more deployments leveraging Bluetooth as an almost de facto standard for location services?
Yeah, what I see happening out there, and it reminds me much of the early days of Wi-Fi, where Wi-Fi used to be a very hard to sell. It was kind of a nice to have. It really wasn't until Intel put Wi-Fi into Centrino and our laptops that really was the catalyst for the whole controller driving Wi-Fi into the enterprise space. I see a very similar thing happening with BLE. We see Google and Apple adopting BLE now and drive it into our mobile devices. Devices drive infrastructure. We're definitely seeing all our B2C customers, hospitality, healthcare, retail, any customer that basically is trying to do some sort of digital transformation inside their venues, they're all pushing towards this. So this is where I'm saying I think this time around we are going to see BLE indoor location services start to move from a nice to have to a must have in all our B2C customers. And we're even starting to see it happen more in the enterprise carpeted customers around space utilization and those type of use cases.
Thank you, Bob. So let's talk a little bit about what does the BLE solution entail in terms of components that have to come together. So taking a closer look at what MIST provides, the fundamental differentiation that MIST has delivered here is both in the hardware layer and the software layer. On the hardware side, unlike every other vendor out there that puts an omnidirectional antenna with one BLE chip on their APs, what we have developed, which is very purpose-built for accuracy for indoor location services, is the 16 antenna element directional array that's built into every access point that we have. And that, in conjunction with the mobile SDK for mobile engagement services, interacts with our unsupervised machine learning algorithms in the cloud. And that's what Bob will speak to you about in a follow-on slide. But that's where, again, our key focus was, yes, we can all transmit BLE signal, but the more signal you have in the air without having to worry about batteries and calibration, the better and better your accuracy is, the more predictable it is, the more reliable it is. Now, that same network that's providing you mobile engagement use cases for blue dot wayfinding or for proximity messaging is also now able to deliver an asset visibility service. And that's what you saw Bob talk about earlier. For example, and we will show you this demonstration, at a very large hospitality customer, they are leveraging our services for wayfinding for guests, for convention attendees, as well as that same infrastructure is also now able to read third-party tags and give you information on where the attendees are when they have badges on their lanyards. So be it a direct push notification, blue dot wayfinding use case, or be it an asset visibility use case, that same directional array built into every infrastructure, our cloud machine learning is coming into play to drive predictable, reliable location services, which are most importantly more serviceable now because everything's happening in the cloud, as well as, and Bob will talk about what we're using from a device perspective as well as an asset tag perspective to drive more an open Bluetooth low energy standards-based platform. So gone are the days we feel of a very siloed infrastructure for location-based services. We are here, we believe, to deliver, again, an open standard-based Bluetooth low energy platform that can cater to multiple use cases. And that is why also we see applicability with those multiple use cases in multiple verticals.
So I think the one thing you'll see at MIST here is you look at the components, right? This is more than just a BLE chip inside of an AP, right? You know, there are 3 or 4 components here that it really takes if we want to virtualize that battery beacon function. There is an SDK there that is actually, in addition to all the BLE information, is fusing together all the information from the phone on the user engagement side. And then on the asset visibility side, there's a whole partner ecosystem lined up for that piece of the puzzle. And then in the converged BLE Wi-Fi side, that is where the array comes in. You know, to provide even better location capability, there's an actual BLE array in there that provides directionality in making the location estimates. And then finally, on top of that, is where all the machine learning comes in and all the analytics that goes behind all that technology.
So the question often comes up saying, you know, everybody touts BLE in the AP, what's different with MIST? What's different with MIST is directionality of the antenna that gives you better accuracy. And that's what drives this patented virtual beacon technology that we have. Now, you know, we've all heard about software-defined beacons and how, you know, every other vendor can say, hey, I can support multiple UIDs on my one chip in the AP. Virtual beacons is not about a software-defined beacon. Virtual beacons is about having the freedom to enable an immersive interacting experience on your mobile device wherever you are on a location. It's not tied to proximity of an AP. It's not tied to a 10-meter radius or a 20-meter radius, because that will be your essentially your coverage of one chip in the AP. It's tied to an actual location of the user and creating very personalized experiences for that user in an environment that MIST is deployed in.
And soonly we'll give you a demo here in a couple minutes here. We'll actually illustrate that even better. Okay. So I want to take a quick minute and kind of go technically deep on, hey, what is this machine learning and how it's actually changing things? So the big thing about unsupervised machine learning here is compared to what I was doing at Airspace 12, 15 years ago, this is actually taking data, the actual RSSI sampling from the devices themselves, and allowing us to do finding this path loss model, right? So this is an RSSI-based system where we're basically having to translate RSSIs into some sort of distance estimate, right? And that is a model that changes for devices and for location. So we're constantly having to learn what is that model for each device and for each AP. And this little technical detail is what we call the probability surface. So when you look at these surfaces, we're basically taking for every beam, right? Every access point, every BT11 has 8 beams coming out of it. We are hearing all those beams. So when I'm sitting there in the middle of space or in a building somewhere, I may be hearing up to 40 beams coming from 5 different BT11s. Each one of those beams is turned into a probability surface that basically is voting on where you think you are in the space. Now, when you add up all those votes, so I've got 40 votes and 40 probability surfaces, that can be translated into what we call a valley of happiness. And this is basically what that algorithm is trying to find. That algorithm is trying to find for every device and for every AP that valley of happiness. And that becomes a table that you'll see inside of the demo here, down here, that translates into a path loss model, which is really the slope and intercept for each device. So that's a little bit of a technical dive. You know, if there's any questions, happy to go deeper. If that doesn't make sense, please raise your hand. And
we do want to keep this interactive. In fact, you know, we're offering a free t-shirt for anybody who has questions, so keep them coming. But Bob, another question for you. So we're doing all this unsupervised machine learning, and we're trying to create a model for every device type against every access point that the device is hearing. What is the key benefit, though, from a deployment perspective, from a scalability perspective?
So this is what eliminates that manual calibration, right? You know, so if you were to talk to Apple right now and they were trying to do the airport, you know, put something in the airport, you would have to manually go through and have someone walk through the airport to actually get all the data and models learned. You know, the goal of this is eliminating that manual calibration. You know, and that has been one of the big friction points with indoor location going from a nice to have to must have, because there's been so much work usually to get it set up and get it running. You know, so now we're trying to turn indoor location into a turnkey, just like Wi-Fi connectivity. You put up the access points, your connectivity works, and your location works at the same time.
Thank you, Bob. That's exactly right. So the whole goal here of delivering this algorithm to the industry was to be able to take away the friction of deploying a location network. You know, again, if you go back in time, you look at people or verticals that wanted to deploy location networks, it was always first and foremost an overlay network. And secondly, it meant doing this manual calibration, manual RF fingerprinting, where you had people walking around the facility, the environment for 10 seconds, stopping, collecting RF signals, walking again, collecting RF signals. All of that is completely negated when you're now driving for a location-based solution to give you, again, an accurate locate for mobile engagement. Bob, so, you know, we talk about machine learning, and the question often comes up is, well, how long does it take to machine learn? And what is my, you know, time is equal to 0, days equal to now experience? So for example, if I take my phone out in this alien environment I've never been in, what will I see? Will it take, you know, hours for machine learning to give me a good dot? What will my experience be?
Yeah. So the good news is, you know, as we get into this machine learning big data, is like we actually have data from all devices across all the networks right now. So we actually have a global view of all the different devices and how they behave. You know, so now I have enough data, I can actually tell you how Android devices compare to iOS devices, which ones hear BLE better, what is the path loss model across all devices. So the good news is we have a very good initialization to the machine learning algorithm, right? We have a global data point to actually start with. And what machine learning is really doing is basically fine-tuning that estimate into the local situation where we're at. So it takes seconds. We're talking about seconds when someone walks into a venue to actually get that location, that machine learning to have effect.
So Bob, I see some questions coming in.
Let's see. Hang on. Oh, maybe.
So the first question is, and thank you, Hardik, for asking the question. You qualify for a t-shirt. The first question is, so considering antenna position, do you think positioning AP in the vertical position would affect asset positioning?
Yeah, I mean, the BT11 right now is designed to be mounted horizontally. You know, the way we have the antenna model set up, everything has been optimized for the BT11s to be mounted flat. That doesn't mean we could not, technically we could mount them vertically, but we'd have to go back and change the antenna models for that positioning. But right now things have been optimized for horizontal placement.
And Bob, isn't that also because since we are driving towards a Wi-Fi, Bluetooth, high resolution accuracy service, typically Wi-Fi networks also access points are deployed horizontally facing around, right? That's your typical design. So
Correct.
The whole goal was characterize the antenna model in for BLE, also assuming that is your typical deployment.
Yeah. But to answer the question, yes, right now mounting the BT11 vertical would affect positioning right now. We'd have to change the antenna model to account for that.
But how would that, there is a key distinction here, Bob, because we have categorized the antenna model for mobile engagement, blue dot wayfinding, but when it comes down to asset visibility, do you think we're still as stringent, or is asset visibility a little bit more lenient in terms of how we mount that access point?
Yeah, you know, between asset visibility and user location, there actually no difference. The only difference between the two services right now is on user engagement, we're actually transmitting 50 to 60 beacons a second down. So that's why we get very good wayfinding, right? Because we're getting so much information every second to make those estimates. On the uplink, we're basically listening on the tag asset visibility service. We're listening to tags that are typically transmitting once or twice a second at most. So from a location accuracy point of view, there is no difference between these two services. The big difference is the time, right? You know, on the user engagement, I'm getting 50 to 60 beacons a second. On asset visibility, I'm getting 1 to 2 beacons a second. So it just takes me longer to get enough information to make that estimate.
Thank you, Bob. Scott, your question, does machine learning occur on a per device basis? How do you compensate for variances between devices or the same make model?
So between, you know, what we have seen, we have not seen a large variation between the devices themselves. You know, between an Android model, you know, between the Android model, we don't see a lot of variation between that. There is an algorithm that actually takes care of if you have an iOS device that say is broken, that tries to compensate for if there's 2 or 3 dB error in that particular device.
Thank you. But overall, I think, Bob, that's again a key benefit of unsupervised machine learning, right? Because we are actually hearing from the device what it hears off the Bluetooth network. So we try and compensate for those variations. So again, folks, keep the questions coming. So far, Hardik and Scott are in the running for free t-shirts. So let's go on now to...
Let me get you the demo.
Yeah, so we'll now give you... We'll now go into our MIST office here in Cupertino and give you a real-time demonstration of the system. Allison, I'm assuming you're able to see our browser. Fantastic. So what you're seeing on the screen, and I know that, you know, we're focusing on indoor location services, and we are talking predominantly about Bluetooth Low Energy, because that is what we feel is the way of the future for high accuracy locate for mobile device engagement solutions as well as for asset visibility solutions. And just to set the stage again, you know, from a MIST perspective, again, we can locate both Wi-Fi and BLE. In fact, if you look at our floor plan right now, we are a single pane of glass, a converged platform that can deliver you location accuracy for mobile application clients, can deliver location accuracy for connected Wi-Fi clients, it can deliver location accuracy for unconnected Wi-Fi clients, it can deliver for passive Bluetooth, as well as named assets. So in terms of what all the system can hear, it can hear anything that's in the domain of Wi-Fi and BLE. But for the purpose of this conversation, we'd like to focus again on the use cases. So passive Wi-Fi, passive BLE is great from an analytics perspective, and customers want to know traffic flows and trends. But when it comes down to delivering an actual use case, you know, in the case of mobile engagement, hey, I want to navigate. I just entered this huge hotel. I want to navigate to the conference room where I'm having my seminar. Navigate me to that room. That's where the mobile app location comes into play. When it comes down to in a healthcare environment, in a retail environment, in a manufacturing environment, hey, tell me where my asset is. Tell me where my associates are with a certain degree of accuracy. That accuracy could be 3 meters, 5 meters, 6 meters, 7 meters. That's where the named asset use case comes into play. And that's again where we are leveraging BLE. Now, another comment you might make is, well, asset visibility has so far been the domain of, either infrared or Wi-Fi or even ultra wideband, more in the active RFID, passive RFID space. Are we now saying BLE is going to take over all those use cases as well? Our stance is very clear. We are delivering, again, an open Bluetooth standards-based platform. We are not saying it can solve all the use cases, but it can definitely solve a lot of the, I would say close to 80% use cases. For example, if you take healthcare, the number one use case that often comes up is, are my assets, or first of all, where are my assets, which building, which floor, and then when you get down to which department and even into which room. That which room use case, BLE can solve. Now you may say, okay, that's fine, but Wi-Fi is solving it already, so why do I need to look at BLE now to solve that problem? What's driving that trend, and you can look at a lot of healthcare verticals going that way, what's driving that trend is the tag economics. If you look at a Bluetooth low energy tag compared to a Wi-Fi tag, you get them, they're much more economical, and therefore you have an immense cost savings when you look at Bluetooth as a platform. So with that background, let's go into the demonstration. So again, we can locate all types of devices, anything on Wi-Fi, anything on Bluetooth, be it connected or unconnected, be it a named asset or just a discovered client. But let's show you, if I focus in on primarily just the mobile app, Bob talked about the unsupervised machine learning. What is that really doing? So this is a real-time installation. We have these devices running in our office right now. We have designed our office to give you in-room accuracy for assets as well as wayfinding around the office. And these are some of the mobile app clients with the MIST SDK on them. Now, when I click on any of these clients, I can actually show you what that device is sending to the cloud. So here you can see all the access points, and more importantly, from all the access points, all the beams that device is hearing. Now, if you recollect, we said each AP has about 16 antenna element arrays, which are transmitting 8 beams per second. Each of those beams is transmitting 4 to 5 signals per second. So in reality, each AP is putting out 40 Bluetooth signals at the minimum in the air. This device can currently hear 4 APs, which means it can hear up close to 160 signals, 40 times 4, of Bluetooth signal in the air. What it's really hearing, though, is what you see here on the right-hand side. So if you focus now on the bottom right of the screen, you can look at the beams per second that the device has heard. So of the 4 APs, which are each transmitting 8 beams, it should be able to hear 32. Given the device variation, and Scott, this is exactly what your question was, given the device variations, given the antenna, given the chipset in every handset, you can actually see what the device is hearing. And that's the information we use to create that probability surface per device and have that path loss formula happen. You can also see these devices are currently static, but if that device was moving, we would also be getting the real-time speed and direction information from the SDK on the mobile device, that which we would fuse along with the Bluetooth-based RSI information. In addition to that, we also are able to give you a view of the round trip time, because another question that often comes up is, especially in our global deployments, hey, if everything's happening in the cloud and I'm walking, 1 meter per second, 2 meters per second, is my dot going to keep up with me? So what you're seeing over here right now is that from that device to our cloud and back to the device, that overall round trip is less than 100 milliseconds. This is real time.
This is actually real time. And I think this is highlighting the scale of this type, and what's highlighting is really the distributed software architecture underlying all this, because this is happening every second, and this can happen at scale. At a very big event, we did this with like 20,000 devices all working at the same time, right? And this is the power of the cloud system, letting it to scale up very fast, very quickly as you add more devices to the system.
Now, this tool not only tells you how the experience of that end user is used like when they're walking around the environment, it also tells you when things are not working, what is going on. And that's another key benefit of this solution. We all know location services till now has been a black box, and either it works or it doesn't work. And when it doesn't work, nobody knows why it's not working. Because we over here are using pure math and pure science to deliver location accuracy, we're looking at all the elements, all the data sets coming into the system that we're using to drive an accurate location. If location is not working correctly, we can easily pinpoint it to, hey, it's a sensor issue on the device. Is the device not hearing enough beams? Is the device not getting enough connectivity? And what is causing that experience to not be optimal as it should be based on unsupervised machine learning? So that's another key benefit here. Now, going deeper into the machine learning aspects here, I'll show you the real-time view of what's happening in our system. So Bob, if you don't mind taking over this screen.
Yeah, so this is actually the detail slide showing you for every device model and for every access point, what is that path loss model? And the green here basically shows you that these are APs where we basically have had machine learning, right? If you look here where it says global versus machine, this tells you whether or not the machine learning has kicked in or if we're using a global PLF model. So this gives you kind of an update of real-time system of how we're learning. You can actually look at the, let's see if I find one here. Oops, I don't want to overwrite it. I was going to pull up the time thing on it. Yeah. So the other key point is you want to have a view over time of how much is changing. So you even get that view of how fast are these path loss models changing over time. So this kind of just shows you the power of the machine learning and how it's actually making a difference now. And just reading, this is one of the key friction points that's going to allow indoor location to kind of move from the nice to have to must have column.
So Bob, another question that comes to mind often is, so far again, location services have been more appliance-based, especially when it comes down to high accuracy location, because people have been concerned about latency. But now we're seeing mobile devices come into the spectrum, and obviously the scale of delivering location services has become exponential. What is the right architecture? Is cloud the right architecture for delivering scalable location services?
Yeah, so one of the interesting stories, when I started the company, we did not plan to be in the BLE business, right? We were basically trying to build a system that could answer questions on par with network domain experts. What that really required us to build, though, was kind of a modern cloud stack that could basically ingest data at volume and process data in real time. And so when you look at indoor location, it tends to have all those same characteristics, right? So we basically had built a system that could basically ingest data at scale, just like LinkedIn and Facebook, right? Same sort of back-end cloud thing. And we also had built a real-time stack in the back end so we could really process data and turn around answers in milliseconds. So that was really the key that really allowed us to basically deliver a real-time location-based services that could solve problems like wayfinding, where you actually have to update that location. You have to keep moving at second type of time frames, right? You got to make things quick. You got to make decisions quick and process things quick.
So Bob, we have a very interesting question here from Hardik again. So he's saying, on your map, I can see user position is changing and shown by the 2 shades of green. So why is the user position shifting even though you're saying the device is not shifting? So Hardik, that's a great question. Let's explain to you what those 2 dots are. So I'm going to go back to our floor plan. I'm going to choose a mobile app client. And then we'll go into the RF environment, or what we call the RF glass screen again, and we'll explain what those 2 dots are. So essentially what you see those 2 dots while the screen is loading up is the first dot is your pure location engine RSI based only dot. And that is reacting primarily to all the RSI beams being heard. But the green dot, and Bob, correct me if I'm wrong, your green dot is your curated particle filter dot, which is what's taking into account the sensor fusion information from the device.
Yeah, so what you're looking at here, and actually you're only seeing 2 of the dots. There's actually 4 more other dots really going around what the gyros are doing and what the RSSIs are doing. Those things are changing every second. This green dot that Sunili's calling the correlator dot, this dot right here, is the actual user, what the mobile app and the user CC. That dot is not moving. That's an integration over time of all the answers bouncing around it.
Yeah.
So hopefully that makes sense. And
so that's how we are building more and more probability for that device type in that location based again on all the information coming in. So you have an RSI only based dot, you have a sensor fusion dot, you have a mobile device sensor fusion dot, not taking into account any RSI, and that's what we fuse and blend together to give you their accurate location. So when you're walking and you stop, you will actually see your dot will walk 1 second and stop right with you. And that is what you see here as the dot that's moving around, which is pure RSI based location engine, which is then corrected or compensated by blending the sensor fusion data.
It makes sense to show them the sites. I think the other thing to point out here, right, this is a tool for what we call day 0. Well, after these deployments are put up, we have a way of basically verifying that the deployment has actually been successful. And so this is basically our tool for making sure that it's happening. There's probably, if you look deeper inside of it, you'll find there's 4 other dots, and there's probably 100 different pieces of information we're gathering at any given time.
So Bob, I'm going to now replay one of the RF Gloss recordings.
So this is something, after one of our partners has deployed one of these solutions, they would actually go through and do this calibration survey to actually verify that everybody meets specs. And what you're seeing here is basically a bunch of different calibration surveys to make sure the system is performing as advertised.
So this is actually, just like in the Wi-Fi world, you have something called Wi-Fi packet capture. This is what we call another industry first, again, from a serviceability perspective, it's what we call a location packet capture. So here again, now as Bob was saying, in RF glasses, you saw 2 dots. Now you're going to see 4 dots. This is primarily from a serviceability perspective. What the end user sees is the most blended, most accurate dot on their phone. But in the back end, this is exactly what the cloud is churning through to give you the best location.
Maybe we're showing the SLE metrics too.
Yep.
Marvis.
So this is, again, it's a rewind of a location walk of an individual user as they're walking around the office. And we're showing you exactly, again, what was the information we were getting in the past from that device. This ties back also into, just like we have service level metrics for location, for Wi-Fi, where we look at pre-connection, post-connection metrics. Similarly, we have service level metrics for location, where we are measuring for a location the latency of the dot, the jitter in the dot that we are sending back to the end user. Are there any teleports happening? Did the dot suddenly go 10 meters away and then come back? And how frequently was it happening? So this again is for our office, where in the last 7 days we are measuring latency, teleports, dropped requests, as well as the AP uptime for the entire site, as well as at every individual client level.
Right. So the same concept, we're using Marvis on the Wi-Fi site, trying to make it easy to answer questions on par with the network domain expert. That same framework is being on the location side, making it easy to ask questions around why a location network is having problems.
Now, the last thing I want to demonstrate for you also is the analytics that we collect. So again, from an infrastructure perspective, we are able to locate Wi-Fi devices, both connected and unconnected, BLE devices, both in terms of mobile app with our SDK, as well as passive BLE, which includes just discovered BLE clients like headsets, Fitbits, smartwatches, or whenever your mobile phone transmits. In addition to that, also named assets, which includes any third-party asset tag that is being used to locate a forklift, a badge on an associate, a badge on an employee, or even your healthcare equipment. We can now divide the floor plan, the site, the map into various zones and give you dwell time information for, again, all the parameters, be it Wi-Fi, be it mobile application, be it BLE. You can choose to filter out any information that you don't want. So example, if you only look at app clients across zones, or you say, okay, show me all Wi-Fi in the zone, you can look at all visitors versus unique visitors. And we actually rank the zones for you. So the ones you see it highlighted in yellow are essentially telling you the max dwell time was in this zone versus the max visitation was in this other zone called engineering leadership zone. And I can go into any of these zones. For example, let's take where our QA team sits. And we can look at historical and analytics around their dwell time metrics in that department, their visitation metrics again in that department, what was the peak hour of day, what was the peak day of week, and in some cases even the individual devices that showed up in that zone with what timestamp and how many visits they had in that department. So not only do we provide, as part of that single pane of glass, the real-time location services across Wi-Fi and Bluetooth, we also can collect data and give you analytics on the past history for either the entire site as a whole or per zone. Any questions? I see some coming in. So the question here is,
On your map.
So this is from Gaurav. Gaurav, you qualify for a t-shirt. You're saying, do you see migration challenges from Meraki to Mist? That's the first question. The second question is, for a software-defined wireless LAN deployment, do you deploy Mist controller, RM in the public cloud or private? And how do you plan to enable countries like India and China? Fantastic questions. So let me take them one by one because there are 3 questions here. Does Gaurav qualify for 3 t-shirts then? Well, we'll see. So your first question, how do you see migration challenges from Meraki to Mist? Well, there are not any migration challenges. I mean, as you know, as we presented in the MFD about 2 weeks ago, we actually have taken key deployments where the customer saw value in the differentiation that Mist was providing, both from a Wi-Fi operational simplicity perspective and leveraging Marvis to answer complex questions, just like a human subject matter expert would. In addition to that, they're also leveraging our built-in location services. So from a design principle practice, nothing really changes. You design your network for high density Wi-Fi location as well as high density Wi-Fi connectivity services. And once you deploy the design as per best practices, you're able to get all the Wi-Fi capabilities as well as the location capabilities. We are a cloud-based infrastructure, as you know already. So all it implies is taking out the Meraki access points, putting in the Mist access points in the best practice on that, based on that site survey, and getting all your Wi-Fi capabilities as well as location capabilities and leveraging virtual beacons.
Yeah. So for our customers right now who are migrating from Meraki to Mist, there is no integration or migration issues, because what they're really getting is they're getting all the benefits of day zero cloud. Instant AP comes up in 15 seconds, and that was the beauty of the cloud, is making it easy to deploy and configure. So all those benefits come in day one. Additionally, what they're getting though is really all the Marvis AI benefit of end-to-end visibility.
Yep.
And that's the real paradigm shift from what I was doing back in my aerospace days 15 years ago. We were really here to help you manage access points. And that's kind of what Meraki is doing too, right? They're here to help you manage and configure access points or endpoints. What we're really doing here at Mist is really around providing end-to-end visibility from the client all the way to the internet. So when you put connectivity services on that, when you really care about that end user connectivity, that is what we're really focused on right now.
So another question that you had, Gaurav, was, for a software-defined wireless LAN environment, do you deploy Mist controller RM in the public cloud or private? And how do you plan to enable countries like India and China? So from a deployment perspective, again, we're a cloud-based service. There is no such thing as a controller. We're a microservices-based architecture. And that has a direct correlation to your RM question. So from a radio resource management, what we deliver is AI-powered RM. Now, what does that mean? So typically, when you look at other vendor solutions, whether they call it auto RF or smart RF or whatever the case may be, that is based more on what the APs are hearing of each other and what they sense as interference in the air, and they respond to either a neighboring AP dying or an issue with co-channel interference or non-Wi-Fi interference. What we do, first of all, we're taking that compute happening in the cloud as its own microservice, so we can add more and more parameters to our RM algorithms in the cloud without impacting the data plane at all. The second key thing is not only do we take into account the AP to AP information, we are also feeding our service level expectation metrics. So we are looking at the coverage SLE, the throughput SLE, the capacity SLE for every wireless client, since we are focusing on the 150 plus state changes of a device as it goes from pre-connection to post-connection, and feeding that information also back into our RM algorithms in the cloud.
Yeah, I think,
Bob, anything else you'd like to add to that?
I think this came up in the mobility field day discussion, really around the concept of controllers. 15 years ago, where we were building embedded controllers and every customer had a controller. As we move to a cloud architecture, we start to talk about virtual machines, right? I'm not building a controller, I'm building a virtual machine that has containers. Inside these containers are all these different services, right? So I'm running location-based services, I'm running RM services, I may be running a roaming service of some sort. Now, the way it works in the cloud is each user's data is segmented such that each user, the services are all being, the customers are all using the same services, right?
Yeah.
It's not like I have one service for one customer, another service for another anymore. I have a set of services that are running on behalf of all the customers. And that's what makes the system so elastically scalable, right? So we just spin up more location services as we need them, right? As we get more and more
or more RM services. Yeah.
So I don't spin up things per customers. I spin up things per messages, right? As I see more requests coming in, I start spinning up more location machines, location estimate engines.
And to your last question, Gaurav, on how do you plan to enable countries like India and China? Well, we already certified for India and China. We actually have deployments today in India. As you know, one of our largest customers is a large online retailer, and they have put us in their warehouses in our international locations. So the next question from you was, well, why do I need the SDK? And you need the SDK because that's what's feeding especially from a Bluetooth mobile engagement aspect, that's what's feeding all the RSI information, all the sensor information that the machine learning algorithms in the cloud are then acting upon and analyzing to give you the blue dot. So the SDK is an intrinsic part for, again, engagement-based use cases on the mobile app. If you're looking at more from a passive Wi-Fi perspective, passive BLE perspective, or asset visibility perspective, there is no SDK component that goes in the mobile app. But if you do want a highly accurate location for mobile app for either push notifications or for blue dot wayfinding, that's where the SDK comes in. And yes, we do have a lot of white papers on our website. Please do go to mist.com resources, and you'll find a lot of videos and white papers. Now, the last thing I want to show you in the demo, we always say save the best for last, is our virtual beacon technology. Now, at MFD, we heard a lot of other vendors talk about, again, I have BLE in the AP2, and you can software define your beacon. What that software-defined beacon essentially doing is you're configuring a different UUID major minor. For those of you who don't know what that is, that essentially is what you configure for an iBeacon signal to go out from your AP. But they don't talk about accuracy. They don't talk about where you want a notification to show up. And that's where virtual beacons come into play. So on this environment, essentially, we've blanketed our floor plan with Wi-Fi signal and Bluetooth signal. And now I can locate, leveraging the Bluetooth information as well as the sensors coming back from the device with my SDK, where you are on my floor plan. Once I know where you are on my floor plan, I can also now interact with you with leveraging this patented technology called virtual beacons. And Bob, was this the fastest patent you ever got?
Yeah,
was with
so
less than 9 months?
Interesting side note, this is the first patent I ever got issued in less than 9 months. So this one went through very quickly.
Yeah. So what are virtual beacons? Essentially, virtual beacons are points of interest where you want to enable an immersive experience directly with the end user via the mobile application. And how do you create these virtual beacons? You do not, again, I repeat, you do not go sticking a battery beacon wherever you want to create a message. All you do is go into the Mist Cloud console, say add a virtual beacon, drag and drop it anywhere on this floor plan where you want to create that message. So for example, let's take it here to our Mist office entrance. And say we can now give a very basic message here that says, welcome to Mist.
Right. And so for anyone who's actually played with beacons, you can see that this looks and feels just like the regular beacon messaging that you would get with a real battery beacon. And this is why we call it, this is what we virtualize, really, is that battery beacon function that Apple and Google have adopted now. The other thing I would point out on this virtual beacon technology is this really came from our retailers. Right, like I say, when I started the company, I really didn't plan to do this, but when I started talking to retailers, they were playing with all these battery beacons, but the problem was every time they changed the store or changed the marketing campaign, they had to go around and move all these beacons around, and they really didn't want to do that. So that was kind of the inspiration for, yes, we can virtualize that function for you.
So again, we avoided RF fingerprinting, we avoided truck rolls, and people didn't have to worry about batteries dying or, more importantly, battery beacons falling off the wall. And as Bob said, a virtual beacon looks, feels, behaves just like a battery beacon from an application development perspective. You can still configure a UUID major minor for a virtual beacon and trigger campaigns off of that UUID major minor. But what it essentially is an XY location on a floor plan where you want to say, I want to trigger a welcome to Mist message. You can also configure a transmit power. Again, there's nothing physical there. So what is transmit power? Essentially, that translates to distance from that virtual beacon location that you want to trigger that message on. And that's what virtual beacons are all about. So we create this virtual beacon on our floor plan. And now, whenever you go to come to our office, and you have the Mist app on your phone, you will see a welcome to Mist message pop up on your devices with the virtual beacon technology. Now, this is completely API driven as well. I mean, a lot of customers ask us saying, hey, I have a large deployment, or I have numerous locations, and do you expect me to go into your portal, into every floor plan and create a virtual beacon every time? The answer is we are an API-first platform. 100% of our system can be configured via APIs. So all you do is go into our system, run a script, and say, create a virtual beacon with this UUID major minor across all my locations at this XY point. And that's it, you're done. So Bob, back over to you now.
Let's go back to here. Let's see, let's go back to our PowerPoint. Oh, this is it.
So we'll now take you into a real live deployment that we have here at the Swan and Dolphin. We just did a launch of this service last week, where we are leveraging the infrastructure for both guest facing wayfinding services via mobile application, as well as ability and attendee to move around through the full Swan and Dolphin facility.
Yeah, so I think the other thing we heard at Mobility Field Day, is this location stuff real, or is anybody using it? So this is an example of a Swan and Dolphin hotel inside of Disney right now, and how they're using location-based services. And what you're seeing here on the left-hand side is the actual app that an event attendee would see inside the Swan and Dolphin. And what they're looking to do is basically start to offer their event planners who come into a big resort these location-based services. And that provides both on the user engagement side and also on the asset side. On the user engagement side, they're starting to embed the SDK, the MIST SDK, into your event app. So you can start having notification and points of interest and proximity messaging show up on the app, and that's what you're seeing on the left-hand side. Additionally, what you're seeing is on the right-hand side is the RF glasses, and this is kind of highlight as someone is walking through that venue, what is going on in real time on the back end to make all the magic happen on the front end. So if you watch this video, let's see here, let's see if I get this down here.
Let me run that for you, Paul.
Yeah. There we go. So what you're seeing here, you're actually seeing someone walk through the event. This is what they see on the app on the left side. This is what they're seeing in front of them. What you're seeing there on the back end is the RF glasses, and actually every second what that mobile device is hearing from the beacon side, in addition to the speed and direction that we were highlighting before. So if you watch this closely, you'll watch the PLF change as he's walking through that event. The path loss model is changing, speed and direction is constantly being updated, and all that information is being fused together with the BLE information plus the sensor information. Is all being fused together to get this experience. You also notice there's kind of an experience we worked on is really getting the map. So as you walk in an indoor space, you really want the map in front of you pointing the right direction, as opposed to your car where you kind of know which way you're headed. You always know you're headed north and south. Yeah. It's a little bit harder in an indoor space to get yourself orientated. So we spend a lot of time getting the angle of direction correct, and that really provides a lot of work with the gyro and compasses to make sure that the map is always pointed the way the user is facing. So that is an example of a real-time location-based experience that the Swan and Dolphin at Disney is doing on the user engagement side. On the asset visibility side, they're using our asset visibility service to really put tags. For those of you who've ever gone to big conferences now, if you're ever looking on the back of your tags, they're starting to put BLE tags on the back of those badges now, so that the event planner or the conference attendees can start doing a better job of figuring out where people are moving through the venue for the event. And this is starting to help situations like when everybody goes to the bar. If I got 500 people at the bar and only one bartender, that's a problem. As many of you found out in your events, right? You need to be able to make sure that you understand where people are moving. They're also using it for compliance checking. If you have an event planner like a medical event, you want to make sure that everybody is going to the right training sessions, right? And they're spending the right amount of time. So anyway, this is the example of hospitality, how they're using the technology. And I think we go to the next slide, we can kind of go over to how we're seeing others, when you look farther across the industry, in the healthcare space, we also just announced the Veteran Administration is deploying this technology for the veterans now. And they're using the technology in probably two different ways. One, on the user engagement, they're starting to look at trying to do what we call Uber help, right? You have a vet or someone come into the hospital in a wheelchair or on crutches. That person may need some help getting in from the parking garage or in from the entrance into their medical event. So the vision is they should be able to pull out their phone, actually call for help, and know someone's accepted that request, and actually see that person come back and help them. On the asset side, and Sunalini talked about this a little bit, is we're starting to see in healthcare in particular, they're looking at BLE as kind of a horizontal standards-based alternative to what has historically been a very expensive proprietary vertical stack for our TLS solutions. So we're starting to see hospitals go pervasive on their BLE Wi-Fi coverage. And what does that really mean? Once you have pervasive coverage, up to now it's mostly been isolated to certain departments. But once they have pervasive BLE, it really starts to open up use cases of tracking down missing equipment, patient elopement. If I have Alzheimer's patients, how do I make sure that they don't get out and start getting themselves in trouble? So those are examples, and you look across the other spaces, in the retail space, we're seeing the same Uber help. We're starting to see retailers who want to basically provide their customers some sort of digital transformation experience. And this really, and I think Sunalini can talk to a couple of different use cases we see there, but Uber help is one of them.
So again, Bob, just taking a step back, right? Going back from your basic premise of location services going from a nice to have to must have. If you look at the journey of location services, it was almost the poster child of healthcare. That's where location services became very critical to locate patients, locate assets, staff duress, patient elopement use cases. And that's where that led to the genesis of a lot of proprietary technologies to help solve that problem. Now, with the advent of BLE, we are seeing location services show up, as Bob said, in retail, in hospitality, in the education space, around safety, around auto check-in the students with the mobile app. Even in the enterprise space, it's all about how do you provide a better experience to your employees as they are trying to find a conference room, or what conference rooms are available near them. Oftentimes, a lot of us, when we are going to look for a meeting room, we will find most meeting rooms are being occupied by people, even though you may have booked that conference room. So how do you solve that problem? How do you increase productivity, well, be it, again, retail, healthcare, enterprise, education, hospitality, leveraging location-based services, and all those use cases, be it an associate help use case, be it finding an available conference room nearest me use case, be it, hey, where's my wheelchair, where's my IV pump, or how many students are going into this auditorium, which is a 600-room auditorium, but hey, only 200 students attended the class. All of the optimizations are being fed a lot by Bluetooth low energy based solutions, either leveraging the asset visibility use case or leveraging the mobile app engagement use case. Now, we do have one more question from Hardik, and I think Hardik, your question is how many virtual beacons we can create. There is no limit to the number of virtual beacons you can create. It all comes down to how many experiences you want to enable for your end users. But there is no limitation in our system of creating virtual beacons anybody you want on a floor plan. And Bob, any parting thoughts, any summaries, conclusions?
No, I think to kind of highlight here, I think we're at the end here.
Yeah.
To answer the question, is BLE indoor location becoming real? I think I just reiterate, I do believe we're going to see indoor location services move from what I call a nice to have to a must have. To reiterate, I think we are starting to see, we now have an interoperable standard in our devices, our mobile devices. BLE, we may see other location technologies getting these devices, but right now BLE is that technology. You're seeing us converge Wi-Fi and BLE together. That eliminates this overlay network problem. So it doesn't add any expense for an enterprise to actually adopt BLE. And we're starting to see the mobile app community start to get more compelling use cases that really are starting to drive indoor location into our mobile experience.